Okay, we're talking about square roots of negative numbers. So let's do it here. The principal square root of a negative real number is going to be defined right here. If a is greater than 0 is a real number, we define the square root of minus a. That makes that a negative number to be equal to I times the square root of a. And every time we see the square root of minus something, we can think of it as I times the square root of the something, as long as the something is a positive real number. So the square root of minus 4 is I times the square root of 4, and the square root of 4 is 2, so that's 2i. So we can write I times 2 or 2 times I interchangeably. The square root of minus 50 is I times the square root of 50, and 50 is 2 times 25. So we get the square root of 2 times 25. And the square root of 25 is 5. So we get 5i root 2. So the square root of 25 becomes 5. Square root of 2 is still there. There's the I. Run out of some space. Hope I don't run out here. Maybe I should move this over too late. Minus the square root of 121. Well, maybe I should make this negative. Minus 121, like that. So that's minus I, the square root of 121. And square root of 121 is 11. Minus 11i. Usually write it like that. You could write minus I11, but ordinarily we'll put the number in front of I if it's a regular old real number, but oftentimes if it's a real number that's a radical expression, we'll put the I in front of a radical. And the thinking is that I times root 2 is hard to confuse, but square root of 2i, it's hard to know where that I is. Should it be under the radical or not? If we stick it in front, we're safe that we don't accidentally include it by accident, or if we needed it, we don't have it. So that's the idea. So we try to make it as easy to read as possible. And so numbers tend to go in front of I unless they're radicals. Radicals go after I. And over here we have products and quotients of square roots of negative numbers. Well, these are those square roots of negative numbers we're talking about. And something unusual happens. We have to be careful about. The product rule does not hold for square roots of negative numbers. We'll kind of see why. If we try to use it, the square root of minus 3 times the square root of minus 27 would be the square root of minus 3 times minus 27, like that. But that's the square root of 81. That would be 9. And the reason why that doesn't work is, well, it would cause a conflict, right? Because if we replace the square root of minus 3 with I root 3, and square root of minus 27 with I root 27, I times I is I squared, that's minus 1. And square root of 3, square root of 27, square root of 81. So you get minus 9. So to avoid that conflict, we say the product rule can't be used for square roots of negative numbers. This product rule only holds for square roots of positive numbers. All right, so what do we do to get rid of that? Well, we first have to convert these negative numbers into I times square roots of positive numbers. Then we can use the rule for radicals for those square roots of positive numbers to get an answer. And that's a way to get only one possible answer, and it's the way the number system tends to work out the best. So we just don't use the product rule for radicals with square roots and other roots of negative numbers. So we get square root of minus 3 times square root of minus 27 is I squared, the square root of 81. I could put it here, I squared. And so that's minus 9. And we'll do some of these other ones. So we'll do the same thing here. I root 5, I root 15. Root 15 is 3 times 5. Maybe I should put it here, 3 times 5, like that. So I've got a couple of square roots of 5, and I've got an I squared, 25, and I've got root 3, like that. So it's 5i root 3. Oh, I squared, 5i squared. I squared is minus 1. Okay, so minus 5 root 3. I think I got it now. And here's a couple of square roots of negative numbers and a fraction. I root 32 over I root 8. The i's cancel. You get root 32 over 8. That's root 4, and that's 2. All right. So that's the introduction to working with complex numbers, where there are special complex numbers. There are square roots of negative numbers. So we can multiply and divide and simplify square roots of negative numbers, as we promised at the beginning of this section. And I want to make sure I haven't messed anything else up here. So the product rule for radicals doesn't work. You have to use the definition to get the I out in front so that the radicals of positive numbers happen. Then you can combine them in the old-fashioned way. I squared is -1. Combine that in the new-fashioned way and get minus root 9 here. Same story here. Root 5 times root 15 is 5 root 3. It is. And over here, the i's cancel. Root 32 over root 8 is root of 32 over 8. 32 over 8 is equal to 4. Root 4 is equal to 2. And there we go. We have accomplished our task. And we're on to the next section, which I will be with you with in a minute. I'll see you then.